In this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet, Exponents and Multiplication. I'll leave a link in the description below so you know how to access this free worksheet. Our directions are to simplify. Your answer should contain only positive exponents. So let's talk about exponents and multiplication. In order to simplify two terms that have exponents, they need to have the same base. And remember, a base is the number or variable that's raised to a given power. So let's start with x to the 2. X here is my base and 2 is my exponent or my power. Now let's say that this is multiplied to another term that has the same exact base. So times x, there's my base, but this time this one's going to have a power or an exponent of 3. Because I have the same base, I'm going to be able to combine those two together. And I can combine and simplify by adding the exponent. So x squared times x cubed will be x to the 2 plus 3, which is x to the 5th. Now, why is that? Let's look at it visually. X squared, or x to the 2, is x times x. And what's x cubed? Well, that's x to the 3rd, which is x times x times x. So here I'm multiplying x 2 times together, and here I'm multiplying it 3 times together. That's a total of 5 times. So x raised to that power of 5. And again, this only works if I have the same exact base. So let's say that as opposed to having an x cubed, I had, let's say, an a cubed. Well, these are not the same base, therefore I will not be able to combine them together. It's already simplified as far as it will go. So taking this quick example, let's try and apply this in number 1. In number 1, we have 4 squared times 4 squared. Let's ask ourselves, do we have the same base? Yes, we do. The base is 4 in each case, or in each term. So I can simplify by adding my exponents. So I'm going to get 4 to the 2 plus 2, which is 4 to the 4th power. Again, seeing this visually, 4 squared is 4 times 4, and this other 4 squared is also 4 times 4. 4 times 4 times 4 times 4 is 4 to that 4th power. In number 2, we have 4 times 4 squared. Do we have the same base? Yes, we do. 4 is technically a base because what's the exponent of 4? That's 4 raised to the 1st power. 4 raised to the 1st power is 4. So I have 4 to the 1st times 4 squared. That's going to be 4 to the, combine those exponents through addition since we're multiplying overall. So 4 to the 1 plus 2 is 4 cubed. Again, visually, 4 to the 1st, well, is just 4, and I'm multiplying that by 4 squared, which is 4 times 4. That's 4 times 4 times 4, which is 4 cubed. Number 3 is very similar to number 1, except our base is now 3 as opposed to 4. But we do indeed have the same base in each of our terms that are multiplied together. So I'm going to write this as 3 to the, adding those exponents, 2 plus 2. 3 to the 2 plus 2 is 3 to the 4th. Again, 3 times 3 is 3 squared, and we're multiplying that by 3 times 3, which does indeed give us 3 to the 4th. For number 4, we're switching things up a bit, this time multiplying not just 2 terms, but 1, 2, 3 separate terms. Can we simplify this? Yes, because they all are a base of 2. Remember, 2 is the same as 2 to the 1st. So I'm going to combine all of these together by adding the exponents. So this is going to be 2 to the 1 plus 2 plus 2. 2 to the 1 plus 2 plus 2 is 2 to the 5th. So 2 to the 5th is our solution in number 4. Writing this out again, 2 to the first is 2. 2 squared is 2 times 2. Another 2 squared is 2 times 2. You can see that I'm multiplying 2 together 5 separate times. 2 to the 5th. Now let's take a look at number 5, because number 5 is a little different. Now, along with the base, we also have a coefficient out in front. But remember, multiplications is commutative, and this exponent is only applied to the n. It's not also applied to this 2. So again, this exponent here is only applied to n. It's not applied to this 5. So I can rewrite this problem as 2 times 5 times n to the 4th times n to the 4th. And why I can rewrite this, again, is multiplication's commutative. So I'm going to take this 5 and 2 and just pull them out in front so that I can visually see them grouped together. So 2 times 5 is equal to what? 2 times 5 is equal to 10. And then I can combine n to the 4th times n to the 4th because I have the same base. Both have a base of n. So n to the 4th times n to the 4th is n to the 4 plus 4, which is n to the 8th. So I have 10 times n to the 8th as my solution in number 5. Let's move on to number 6. Number 6, we have bases that are the same. We have an r and an r squared, where that r is the same as r to the first. And we have coefficients out in front, 6 and 5. So rewriting this quickly, I'll have 6 times 5 times r to the first times r squared. And again, that's because multiplication's commutative. So I can combine 6 times 5 to get 30, and then I can combine my r to the first times my r squared, which I can combine those or simplify them because I have the same base. I can add the exponents. So this will be 30 times r to the 1 plus 2, which 1 plus 2 is 3. So this is 30 times r to the third, or 30r cubed. Let's move on to number 7. In number 7, I have 2 n to the 4th times 6 n to the 4th. Remember, I can combine my coefficients through multiplication, and then I can combine my n to the 4ths because I have the same base. So I'll have 2 times 6 times n to the 4th times n to the 4th, which 2 times 6 is 12, and n to the 4th times n to the 4th is n to the, add those exponents, 4 plus 4. So 12 times n to the 4th is 12 n to the 8th. Let's move on to number 8. Number 8, I have 6k squared times k, where this k is k to the first power. And the coefficient out in front is just the 1. So I'll have 6 times k squared times k to the first, which is k to the 2 plus 1. 6 times k to the 2 plus 1 is 6k to the third, or 6k cubed. Number 9, 5b squared times 8b. Remember, 5 and 8 are just those coefficients out in front. So I can combine b squared with b because I have the same base. B squared times b to the first. 5 times 8 is going to give me 40, and I'm multiplying that by b squared times b to the first, which can simplify down to 40 times b to the 2 plus 1, adding those exponents since I have the same base, which is 40b to the third, or 40b cubed. And number 10, do I have the same base? I do indeed. I have an x as my base in both my terms, and then I have a coefficient of 4 and a coefficient of 3. 4 times 3 is going to give me 12, and then I have x squared times x to the first. So I have 12 times x to the, adding those exponents of 2 and 1, 12 times x to the 2 plus 1 is 12 times x to the third, or 12x cubed. Moving right along, I have 6 times x times 2 times x squared. So my x's are indeed the same base, where this x is raised to a power of 1. 6 times 2 is going to give me 12, and x to the first times x squared is going to be x to the 1 plus 2. Again, combining those exponents through addition since I'm multiplying those terms. That's going to be 12x to the third, or 12x cubed. The same answer as in number 10. The last problem on this first page is number 12. If you've stuck with me so far, don't forget to click that thumbs up button. And if you know somebody else that'll find this video helpful, feel free to share it along. For now, let's finish out this first page. We can combine our coefficients of 6 and 6 together, and x is indeed the same base. We have an x to the first and an x to the third. So I'm going to start with my 6 times 6, which is 36, and that gets multiplied by x to the first times x cubed, which is x to the 1 plus 3. Adding those exponents, since we're multiplying the terms and those exponents had the same base. So this is going to become 36 times x to the 1 plus 3, or x to the fourth. Here on the next page, we take a jump up in level of difficulty. But remember, in order to simplify, we have to have the same base. And also remember, multiplication's commutative. So what I'm going to do is I'm going to start out by rewriting 13, trying to group my similar terms in similar areas, just so visually I can see what's happening. So I have a 7, 10, and 8 as my coefficients of these different terms that contain both u's and v's. So I'm going to write my coefficients multiplying those together at the start. So I have a 7 times 10 times 8. So there we go. I took care of the 7, 10, and 8 right here out in front. Now I want to find terms of a similar base. So I'm going to look for all my terms with a base of v. So I have a v cubed. Then I have a v to the fifth. Then I have a v cubed again, or a v to the third. So now I have all of these bases kind of grouped together visually in the same area. And then lastly, I have two terms that contain a u. I have u cubed and I have u. So I'm going to write those as u cubed times u to the first power. Now it's just a matter of combining what I can. 7 times 10 times 8. Well, 7 times 8 is 56. Multiply that by 10, we're going to get 560. And then in order to multiply my next three terms together, since they all have the similar base, I will add those exponents. So this is going to be multiplied by v to the 3 plus 5 plus 3. And then lastly, my base of u will be to the 3 plus 1. Simplifying this down one step further by actually doing out those additions, I'll have 560 times v to the, 3 plus 5 plus 3 is going to be 8 plus 3, which is 11, times u to the 3 plus 1, which is u to the fourth. So here we go. 560 times v to the 11th times u to the fourth. Let's continue on to number 14. For number 14, I'm going to keep combining visually like I did before until we get used to the grouping, and then we can go from there. So multiplication is commutative, so I'm going to write my 9 times 9 first. Then I'm going to find my like bases. So x to the first can be combined with x to the fifth, so I'll write that next. And then lastly, I can combine my y's, since y squared can be combined with y squared since they have a similar base. Now, 9 times 9, that's going to give me 81. Multiplying that by x to the first times x to the fifth, which, same base, so add those exponents together. And then y squared times y squared, same base, so add those exponents together. This is going to give me 81 times x to the 1 plus 5, which is x to the 6th, times y to the 2 plus 2, which is y to the 4th. So here we have our solution for number 14, 81 times x to the 6th times y to the 4th. For number 15, combining my coefficients of 6 and 8, I'll have 6 times 8, which is 48. Then that's going to be multiplied by m to the 3rd times m squared, where m to the 3rd times m squared is going to be m to the 3 plus 2. And then lastly, my base of n cubed can be combined with n cubed, where n cubed times n cubed is n to the 3 plus 3. Now simplifying this down, I have 48 times m to the 3 plus 2, which is m to the 5th, times n to the 3 plus 3, which is n to the 6th. That's my solution for number 15. And remember, again, multiplication is commutative, so if you had this n to the 6th before m to the 5th and had 48 times n to the 6th times n to the 5th, that's also equally okay. Let's move on to number 16. Number 16, we have 6 times x squared times 6 times x cubed times y to the 4th. So 6 times 6, I'm going to start out by writing. Then I have my x squared times an x to the 3rd, same base, so I will be able to eventually simplify those together. And then y to the 4th is the only one with a base of y, so that will get multiplied as well. But it won't be able to be combined with anything else. So 6 times 6 is going to be 36. X squared times x cubed is x to the 2 plus 3. And then times y to the 4th. So this is going to simplify to 36 times x to the 2 plus 3, which is x to the 5th, times y to the 4th. 36 times x to the 5th times y to the 4th is my solution for number 16. For number 17, you can see that we have two different bases we're going to be working with. We have a base of u, and we have a base of v, and also two coefficients out in front, 7 and 9. So starting with 7 times 9, I'm going to get a positive 63. And then u squared can be combined with u to the 1st by u to the 2 plus 1. And then we're going to be multiplying that by v to the 5th times v cubed, which is v to the 5 plus 3. So we're going to have 63 times u to the 2 plus 1, which is u cubed, times v to the 5 plus 3, which is v to the 8th. And there we have it. That is number 17. Number 18, what are my different bases? Well, I have a u, I also have a v, and I have a coefficient of 4. So this is going to be 4 times u to the 1st times u to the 1st is u to the 1 plus 1. And then I have v to the 1st and a v to the 5th, which is going to be v to the 1 plus 5. So I have 4 times u to the 1 plus 1, which is 4 times u squared, and that gets multiplied by v to the 1 plus 5, which is v to the 6th. So here we have it, number 18, 4 times u squared times v to the 6th. In number 19, we can combine 10 and 8 together to get a positive 80. We can combine our bases of x together to get x to the 1 plus 5, since this is an x to the 1st times an x to the 5th. And we can combine our y cubes together. So that's going to be times a y to the 3 plus 3, since both are raised to the 3rd power. So this is going to be 80 times x to the 6th, since 1 plus 5 is 6, times y to the 6th, since 3 plus 3 is 6. So 80 times x to the 6th times y to the 6th is our solution in number 19. In number 20, combining our coefficients at the start, 3 times 7, that's going to be a positive 21. Then we can combine u to the fourth and u squared since they are the same base. So that's going to be u to the 4 plus 2. And then finally, we're going to be multiplying our v to the fifth with v cubed since those are the same base of v. So it's v to the 5 plus 3. Writing this out, we're going to get 21 times u to the 6th times v to the 8th. 21 times u to the 6th times v to the 8th is our solution for number 20. Let's move on to number 21. Now in number 21, we're mixing things up because look, we have parentheses around our term 2x squared, but then that itself is squared. So what are we going to do with this exponent in this case? Well, take a look. Think about what exactly is 2x squared squared. Well, when we square something, we're just multiplying it to itself. So we have 2x squared, and we're multiplying it by 2x squared. That is 2x squared squared. So how would we combine this? Well, just like before. The coefficients, 2 times 2, that's going to give us 4. And then we can combine our x squared with our x squared because they are the same base. So that's going to be x to the 2 plus 2 or x to the fourth. So we're going to get 4x to the fourth as our solution in number 21. However, there's an easier way to think about this. Because we have a base of 2x squared and we're raising it to an exponent of 2, think about this term inside those parentheses. Because we have parentheses around the 2 times an x squared, we can apply this exponent to the 2 and to the x squared. So this could also have been rewritten as 2 squared times x squared squared. 2 squared, well, we know that that's going to give us 4, but what is x squared squared? When we have an exponent and we're raising it to another exponent, they don't get added, they actually get multiplied together. So then that would become our 4, which we've already calculated, times x to the 2 times 2, which becomes x to the 2 times 2, x to the fourth, so that's 4x to the fourth. So again, when we have an exponent outside of parentheses, we're taking a term and raising it to another exponent. When it already has an exponent, those get multiplied together. So let's take a look at this even further in number 22. In number 22, we have p to the fourth raised to the fourth. What are we going to do with those exponents? We're going to multiply them together. So this is going to be p, that base, to the 4 times 4, which p to the 4 times 4 is p to the 16th. That's our solution in number 22. Another way we could think about this is we could write out that p to the fourth raised to the power of 4. So we have p to the fourth times p to the fourth times p to the fourth times p to the fourth. And how we write that out is we have p to the fourth multiplied 4 separate times. So here we have it, 1, 2, 3, 4 separate times. And because we have it 4 separate times, now we just add those exponents together to get p to the 4 plus 4 plus 4 plus 4. 1, 2, 3, 4 times. 4 plus 4 plus 4 plus 4 gives us that 16th. That's why we can multiply at the start. Otherwise, we just write it all out and wind up adding it multiple times where we could shortcut and just multiply it at the start. Let's move on to number 23. In number 23, similar to that of number 22, we have a term raised to a power. What are we going to do with those exponents? We have a k cubed raised to the fourth, that's going to become a k to the, we multiply the exponents, so 3 times 4. K to the 3 times 4 is k to the 12th. Again, seeing this visually, k cubed raised to the fourth is going to be k cubed times itself, k cubed, times itself, times itself. That is k cubed to the fourth power. 1, 2, 3, 4. What this then becomes, using our previous methods, since we have the same base, adding those exponents, k to the 3 plus 3 plus 3 plus 3. This is k to the 3 times 4, since we're adding 3 together 4 separate times, or k to the 12th. Moving on to number 24, we have 7k squared. Remember, this exponent is applied to the terms that are multiplied together within these parentheses. So this squared is applied to the 7 and it's applied to the k. So I can rewrite this as 7 squared times k squared, because that's k to the first squared, which is k to the 1 times 2, or k squared. 7 squared, 7 times 7 is 49, and that gets multiplied by k squared. So 49k squared is our solution in number 24. Again, thinking about this, as opposed to distributing the exponent, let's think about it as 7k times 7k, because that is 7k squared. 7k multiplied 2 separate times. Here we have 7 times k, which is going to give us 7 squared times k squared, or 49k squared. Number 25, x squared raised to the power of 3. What do? Since we have a term with an exponent raised to another exponent, we're going to multiply those exponents together. So this becomes x to the 2 times 3, which is x to the 6th. Feel free to double check by writing out x squared cubed and adding those exponents together to double check. Lastly, on this worksheet, number 26. Number 26, we have 2 times b squared, all raised to the power of 4. How we're going to start is we're going to distribute this exponent in to our coefficient of 2 and to our term of b squared. So this is going to become 2 to the 4th times b squared raised to the power of 4. 2 to the 4th, we can simplify down. That's 2 times 2 times 2 times 2, which is 16. B squared to the 4th, what do? We have a term that already has an exponent raised to another power. We multiply the exponents. So this is going to be 16 times b to the 2 times 4. So 16 times b to the 8th. That's our final solution on this worksheet. If you have any questions, please feel free to leave them in the comments below, and I or one of your peers will get back to you as soon as we can. But as always, don't forget to like, subscribe, and share. Happy learning!